Right. So how do we do this? We have those names, so we can get vertices that have these values in the dictionaries. So we have something called graph vertices by key value, or vertices at key value, excuse me. All right. The key, and I think it's wrong in the PDF, it says type. It should be name, because that's what we called it. I changed it at a certain point. So the key is name, but the value is coming from those, from these values that are coming from these list items, excuse me. So, all right, so let's go ahead and get the vertices. How to get the vertices? Where do these vertices come from? These come from something called graph.vertices. Graph.vertices here, you give it the graph, it will give you all the vertices of the graph, as you can see here. We give it those, and we give it these values, and we should get the vertices that have these values in it. So we have 1, 2, 3, 4, 5, 6, 7, 8. We know that we have 8 dictionaries. So we do the same thing here. We copy this and paste it, and we give it the same global list of vertices, all the vertices of the graph. The key is called name, but now the values are different. And those are the other 8 vertices. Obviously, there's overlap between them, because entrance to entrance, entrance to bedroom, bedroom to bathroom, etc. So now we find the shortest path. So we are getting close to the end. So find shortest path. Oh, not shortest path. Where is it? Shortest path. Choose the one that is singular, not paths. Just we want one path, not all the shortest paths that are available. And okay, so let's see what it's looking for. A graph, a vertex A, a vertex B. So we're just going to give it, let's put it next to the graph, bring it closer to the graph. Where's the graph? The graph is this one. So we give it this graph, and then you give it the list of vertices from the first list, the list of vertices from the second list, and we have a wire. So let's check that we have a wire. So we have 8 wires. 1, 2, 3, 4, 5, 6, 7, 8. 8 wires. We can see it here. Great. So let's draw those 8 wires and see what they look like. So again, look for topology.geometry and control-click on them. And here are the 8 wires. It looks like they are the same as the graph itself, but they are like really overlapping. So that's why I separate them. Right, so let's go ahead and get the wire lengths. So we can go and say wire.length. So this is step 19. So we take those 8 wires and we find their lengths. So here are their lengths, maybe in meters or something, but these are the lengths. And we can now normalize those lengths from 0 to 1. So what I will do is I will take the maximum value, I will divide by the maximum value, because obviously the minimum value could be a 0. Like, the wire is very, very short, could be a 0. So I can assume 0 is my minimum value. I don't have to worry about that one. But I will take the maximum one. The maximum one here is obviously 11.7. And I will divide every number by 11.7 to get a number between 0 and 1. So let's go ahead and do that. So we can do list math, and we can find the maximum, and we are operating on level 1, and we can go here, connect the data to it. No, it's not correct. So we are operating on what, level 2? No, level 0. Yeah, level 0. And I don't need to wrap it, I think. Right, so I'm operating at level 0. Don't know why. Here it's a bit different than the instructions. But what you need to do is get like 11.7. I'm not sure I need to wrap it like this in another list or not. It all depends on where it's going to be fed. But I do it by trial and error. If it requires something to be wrapped twice, which is an idiosyncrasy of Sverchok, they require things to be wrapped twice sometimes. We'll deal with it that way. But then we can do scalar math. So we can do scalar math to divide. So here's divide from the pull-down list. We'll divide these wire lengths by this maximum number. And let's see what we get. Yeah, see, it's out of range. So I don't wrap it, or I do wrap it. What is it? Or I wrap this one. Maybe I need to wrap these. So how do I wrap a node, an output node? What you do is you open up the side panel here. You click on Sverchok. You click on 3 UI options, and you click on socket menu. And you have now a socket menu here. You can then choose to wrap it or not wrap it, and you get the numbers. Now it's all one, so that's wrong. Okay, what am I doing wrong here? So I'm wrapping this, I'm wrapping that, but now this is a query. Because now I've wrapped it, yes. That's why now it is correct and according to the PDF. Because I have wrapped it here, this has to be level 1. And then that will work. So they're both now wrapped correctly, and therefore this works, the division works. And therefore you get numbers between 0 and 1. So this is now normalized, as we call it. Great. So we can get now the adjacency scores and also normalize them. So the input is from whatever was in step 15. So let's go ahead and do that. So basically, we are going to go back to here. Right. This is from the Python script. We're going to get list item 3. So let's get list item from the data. And let's check what it looks like. Oh, gosh. So, right, so we need index 2. And we are going to, what is it saying here? This is score. Let me, it's not clear on my printed thing. So let me just go ahead very quickly, show you it's step 20. Gives you a chance to catch up perhaps a little bit. Right. Right. So you'll notice that what I'm doing is they are in text, so I need to change them to a number and then feed them into the divide and get the maximum and all of that. And it looks like I'm also, maybe I don't need to wrap them because they're already wrapped. Okay, so there's something called string tools. So we'll go ahead and do that. Because these are strings. So we look for string tools. And we say to number. And we feed it those. We get numbers. Great. So we do the same thing. So let's go ahead and bring this over to the other ones, because they are very similar to what we're going to do here. So we're going to create the same logic here. We can copy that. So we're going to find the maximum, first of all, of these numbers. And then we are going to divide them and see what we get. Again, so this is now the scores. And you can kind of compare, it should be, it should be 0.33, but it ended up 0.328. It should have been 0.667. It ended up being 0.634. So these are comparable to each other. And that's how we are going to determine the color coding. From here on, it is really graphics. So basically, we do a subtraction. So again, scalar math. And we subtract. Doesn't matter which one you're going to subtract because we're going to get the absolute value. So you just subtract one from the other. And then copy and paste it. And there is something called absolute here. Feed that in. And let's take a look at the numbers. These should be very, very small numbers. Yeah. Right. So these are the small numbers here. Okay, fantastic. Fine. So we did step 21. We convert the difference into a color. So what we have is something called, well, let me open up the PDF again, because the printing got worse there for some reason. So there's something called color by value and range. So this is the minimum and the maximum, and we can put 0 and 1 here if we wanted to, but that's absolutely fine. And then we get the difference in color. So color by value and range. SVRJOC has its own color range as well, but so you can use whatever you're comfortable with. So color by value and range requires the value, which is this one. And then we can say minimum is 0 and maximum is 1, just to save a bit of time. If you click on this one, you should see red, green, and blue. These are the colors. And they're wrapped correctly, I believe. We might need to wrap them, actually, sorry. I think we need to wrap them. So go ahead and wrap these. I think they need to be wrapped like this. And then we separate the wires vertically for better visualization. So we're in the home run of this. So what we are doing is find out where the wires are. So hunt for it. Graph shortest distance, right? So we need to go look for shortest distance. From step 13. I need to find them. Values, blog. Here we go. Shortest path. Sorry, not shortest distance, shortest path. These are the wires. So what I can do is find the list length. And we're operating on level 0. So this is 8. So we can do now a number range. Number range, and we'll go float, we'll do step. This just gives us a range. We'll start at 1. Just to go up, we step by 0.15. And the count comes from how many wires we have. So if you look at that number range, you'll see it is 1, 1.15, 1.3, 1.45, etc., etc., etc. There should be 8 of them. 2, 3, 4, 5, 6, 7, 8. And then, so this gives us some translation values in the Z that we can apply to the wires. So we can do topology translate. Translate means move. So we give it those 8 wires from the original shortest path, but the Z values will be given by this list here. And just to check your work, you have now 8 new wires, and those are separated. So let's go ahead and draw those wires. Oops, sorry. Let's go for topology.geometry. And then control-click on it in order to see the wires. So those wires are separated in the Z-axis. Now we can immediately draw them with colors. So we can go ahead here and say, the edges, first of all, we can make them a bit thicker. So let's go ahead, maybe make them a bit thicker like this. But this yellow one, this middle one, is the color of the edge. So you can feed it colors. So now we have those colors here. We can feed those colors in there. And they are all coordinated in the same order. And here are your colors. So everything looks okay. If you don't get reds, that's a good sign that you have satisfied the adjacency matrix. I'm going to skip step 24. It's a final garbage collection. This is just optimization, etc. So you can move these things around now and then rerun the whole thing if you want. So let's do this in the plan. Take this to where the bathroom is, bring the bathroom here, and then re-update all the nodes, and you get new colors and new values. Good, we finished pretty good, not bad on time. I will look at the chat and see if you guys have any questions. All right, Bruno, each cell will know its name now, but how does it work with the faces? If transfer to faces is selected, a face is shared by two cells will inherit both names? No. A face, if the locator that has the dictionary happens to be onto the face, it will give its dictionary to the face. The face will not, if the dictionaries are applied to the cells, the face, all you need to do is ask the face for its cells. It will give you two cells. Then ask each cells for its dictionaries. It will say, oh, I'm a living room, I'm a dining room. And if you would like to make a new dictionary for the face that says living room, dining room, that's up to you. But the topology is there, so you can always get the information. How do you compare Dynamo, Grasshopper, and Blender? Oh gosh, I hope there's nobody. Dynamo is where I started, so it's near and dear to my heart. It's connected to Revit, obviously, so it has its own utility by connecting to, a very popular BIM platform, obviously. So we've been connecting it to TestFit. It has these types of advantages. But unfortunately, out of those three, Dynamo is the slowest. Grasshopper, when we moved to Grasshopper, we noticed a really significant increase in speed. And Grasshopper, obviously, the advantages of Grasshopper is the huge ecosystem of add-ons. I mean, Food for Rhino is unbelievable, how much stuff it has. Nothing compares to that. So if you are working with a lot of other plugins, Grasshopper is the way to go. Blender is I love it. I absolutely love it because it's fast. It's the fastest of all of them. Open source, extensible. It's just, and because now it is Python. I mean, remember, Topologic on Dynamo and Grasshopper is C# and close, and it's and C++. It's difficult to update. With Blender, we have now did the Python bindings for Topologic. So you can download just a pure Topologic Python node or module and use it in anything else you want that uses, you can put it in Jupyter Notebook and stuff like that. So it is the future, definitely, for me. But we do need the support of the open source kind of movement because, we need a lot more plugins and we need to create an ecosystem. Right, sorry, Pedro, I got stuck between step 16 and 17. Where does the graph.vert connect from on the left? Graph.vertices connects to the graph, to the actual graph by topology. So graph.vertices is here. On the left side, it's graph, so it comes from the graph. Right. So Max, thank you very much. Can you please explain the aperture? Are there faces with inside wires after the intersect operation? Okay, apertures do not subtract themselves from the faces that they are on. They are like stickers. So they're just faces on top of faces. So a face, a wall, like one of those interior faces, can have an aperture, and you can ask it to give you a list of its apertures. Those apertures, even though they're called apertures, they end up being topologies. They end up being like a vertex or a face. Usually it's another face. But I do not do a Boolean operation where I intersect them. I did the intersection just to get the actual kind of face that looks like a door, but then I applied it almost as a sticker. Since the room name is reduced to a vertex host, couldn't you use a point object like an empty to assign function? Oh yes, absolutely. I chose a cube so that I can see it and move it around, but it's just a location, so it could have been just a single vertex that has a custom attribute. It's giving me only one vertex on the outside. Pedro, I don't know what that is, sorry. Mohsen, the PDF and everything is on that short link that I gave you. Let me see if I can quickly get it from here. If you want to do a screenshot, all the files are there. Julia, can we generate a 3D graph for a 2-story building? Absolutely. Our graph is fully 3-dimensional. You can have 100 stories and it will connect in 3D and you get like a lattice kind of wire mesh. Yeah, absolutely. Let's see. I'm just curious how many participants. Oh, not too bad. We didn't lose a lot. We started, I think, with 45. We came down to 32. So thank you, everybody, for sticking with it. If you need anything, any other thing, just find me. I think I'm on Discord. I'm on Twitter, on LinkedIn. Email me. By all means, get in touch and get more information. I will upload this video obviously to YouTube once it's finished. You probably by tomorrow or day after tomorrow you'll find it as well, and I'll tweet about it. So I'll stick around until 6 o'clock to answer any questions if and see. But please feel free to leave if you are done with it. Could we have a model where objects were separated by name and the original selections would stem from those names? This would avoid all modeling and intersecting in Blender. We could just model it outside, import it, and apply the nodes to it. Could we have a model object? Yes, you could bring in, you can model it somewhere else and bring it in as a BREP or bring it into Blender already with names, and then build a cell complex by cells. So if you have like different rooms, but those rooms need to be touching. You cannot, if they're separate, they'll end up with a cluster, and therefore the graph will not connect. It cannot, jump over vacuum. It has to have a shared face. Can you post your final file as well so we can inspect it? Please? Absolutely. I was planning to add it to the zip file, and I will update it. Is Blender interactive to the virtual graph? When I move a door, the graph does not change. No, it does not do that. I was just reading about it actually today. These events are not. So unfortunately, you have to click on re-update all nodes in order for it to accept the change. But it's not like in 3D Studio Max, when you move something, you can actually get a callback event saying something has moved, and then maybe I can re-trigger the Sverchok definition, but no, it does not do that. Where can I find the recording? I will put it on YouTube. You will find it under my channel. So if you go to YouTube and look for Wassim J, W-A-S-S-I-M-J, my name, I have a playlist called Topologic Sverchok, I think, or something like that. You'll find it there. And I will tweet about it as well. What are some other usage of Topologic besides finding the path? Oh my gosh, it's a lot. You can use it for energy analysis. We are trying to connect it to IFC and Blender BIM. So you're gonna, if you take a look at Bruno Postel's homemaker, he used Topologic as the engine inside his software. So he takes, a very simple cell complex and creates a very advanced BIM model out of it. It's really endless. We've used it for AI and machine learning. I have a couple of PhD students working on that. It really is endless. Take a look at some of the presentations I've done, at University of Oregon and other places. I talk about how it could be applied. I'm interested in using topologic for space planning analysis in Revit. What's the best resource for me to get started with constructing a topologic graph from Dynamo? The learning page says forthcoming. A lot of it is forthcoming. It's really very similar. Excuse me. It's very similar to what you've seen here. So graph by topology is the same. So just create a topology. Create a cell complex in Dynamo. Do graph by topology, and you go from there. It's all there. Some of the early tutorials and workshops I've done were using Dynamo as well, so you can take a look at that. What about a non-manifold model where an envelope is divided by faces? This wouldn't be a collection of solids, but just faces. No, it would be a cell complex. So if I got a building envelope and I slice it, Topologic builds the highest possible the most useful topology. So it will not be just faces. If it is just faces, and it's open, let's say, you have an enclosed cell, it will be a connected shell. And you can do a graph on a shell, but then the vertices would be like in the middle of faces, and they would go through edges to go to the other face. Like imagine a cardboard box that is unfolded or folded, but not closed. The dual graph will be right on the surfaces. So it's like a terrain. So it depends on what you are trying to do. But if your end result is enclosed cells, enclosed spaces, you will get a cell complex. Can you read in a CSV and use it as a dictionary? Yeah, with a little bit of a Python thing or a little bit of a code. Yeah, not even with the Python. You could get the values and you can say dictionary by keys values. So you have something here called, oh, not here, by keys values. So you can give it two lists, a list of keys and a list of values, and you get a dictionary. And those keys and values can be coming from the CSV like we did. Energy modeling, which your PhD student project is most worth checking out to start getting an idea about the scope of use here. I have 3 videos recent that show you how to use OpenStudio and Energy Plus and how to build an energy model from Topologic. So under Topologic, you'll find that there's something called energy model, and I have all the OpenStudio stuff here. So you can get an OSM, GBXML, all of that. And there are 3 videos on my playlist that take you through how to create an energy model and simulate it. And you get all the colors inside Blender. Are you still working with the Puro-Happold BOM model? Not actively. They have it inside. There is Topologic is now integrated with their BOM. It's also integrated with something called SAM. So somebody, Mikhail Degonziak, who was working with Puro-Happold, left them and went and worked with Horlia in Bristol. And he reinvented the same concept, I would say, but maybe changed it a little bit. You can ask him about it. And SAM 2.0 also includes Topologic, very much like BOM does. But it's all in there, yeah. But I am not actively like working with them. That project has been the same way for some time now. Use of Topologic with IFC, watch this space because we are, I'm planning on learning IFC. I don't know IFC very well. Obviously, it is something that, we should connect Topologic to. Homemaker is the first instance where Topologic objects became IFC, but they are hard-coded and they are using the style that Bruno is interested in, which is this kind of neoclassical style. Obviously, we need to bring it into SphereChalk and to be able to create IFC entities and thicken the walls correctly. There are some issues today. I've been conversing with a lot of people on Twitter about how we would thicken a single face into an IFC wall. It's not easy. It's not like trivial. But I'm absolutely determined to connect Topologic to IFC. All right. We are right on time. If there are no other questions, I wish you a very good weekend. I hope you enjoyed this workshop, and I look forward to seeing the work that you're doing with Topologic. So stay in touch and please tweet about it. Bye, everyone.